Welcome class. This is our lecture on property of Laplace transform, and today we are going to study about convolution property. This is the last property that we are going to study in this series. Convolution property, it says that Laplace transform of ft star gt is f of s and g of s. G of s is the Laplace transform of ft and g of s is Laplace transform of gt. These are the standard representation. Now we have to define what actually this ft star gt means. Ft star gt is our integral, that is, it runs from u is equal to 0 to t f of u g of t minus u t. Alright, now we are going to put this into this one and we are going to prove that it is the transform of those functions respectively. So this becomes f of t star gt Laplace is equal to, what is the definition of Laplace transform? That is 0 to t is equal to 0 to infinity, and the function, our function is ft star gt. So we can write it as u is equal to 0 to t f of u g of t minus u, and for this one we have to write as e to the power minus of st dt. Alright, now what we are going to do from here onwards, that we are going to change the order of integration. Our order of integration is du by du dt. Now we are going to change it to dt d. How do we do that? We just try to see the picture. Here t runs from 0 to infinity and our u runs from 0 to t. So if we plot it like this, this is your u is equal to t. So this is our transformation. What is u is equal to 0? This is our this domain. So this is the vertical strip and t is 0 to infinity. Now we are going to change the order. So when we do so, what it becomes? This is our t, this is our u. So our strip becomes, here t is equal to u to infinity and u is 0 to infinity, means this one. So now we can change the order. So that will be u is equal to 0 to infinity and t is going to be u to infinity. Alright, so we can write it like that, e to the power minus st fu g of t minus u dt d. This is fine till here. Now I will try to write this equation at the front so that I can solve it. So our integral is u is equal to 0 to infinity and t is equal to u to infinity e to the power minus st fu g of t minus u dt d. So we are going to put t minus u as v. So this we are talking in terms of t and v. So this remains a constant. So when we put t minus u is equal to v, then we have dt is equal to dv. Now we plug this here, t is equal to u. So if we put here t is equal to u, what happens? V is equal to u minus u, that is 0. Now if we put t is equal to infinity, then v is equal to infinity. So our e to the power minus s, what is the value of t here? Value of t is u plus v. So we can write fu as fu because we are changing this t with respect to v, not with u, and this t minus u is v, so this becomes gv. So in place of dt we get dv, and du is just copied as it is. So this becomes our integral. U is equal to 0 to infinity. What we can do, we can separate all of this. So su fu du, this is our one integral, and this is our another. V is equal to 0 to infinity e to the power minus sv f v dv. This is our second integral. So this is, we have always studied that this is the integral with respect to this one. So whatever be the coefficient of this minus u, that is the transform. So this is, so what it is fu, and this is gv. So there is a rectification. So this is our gv dv. So this is our fs, and similarly we can write it as this is in terms of v. So this is our gs. So this was our claim, and this is what we have proved. So with this we have given you an understanding of convolution property. Now why it is important for civil services? Because there are certain questions that has been asked. Not only that, when we will be studying application of second order differential equation using Laplace transform, there will be some particular integrals where we have to be using this formula and integrate to find this. So now we are going to take a question based on the convolution property, which was asked in IES 18.7. The question says that if function ft is equal to t to the power p minus 1 and gt is t to the power q minus 1 for t is equal to greater. So we are taking for the positive values. And for ft and gt, both are 0 for negative values. And this ht is a convolution, ft star gt. And we have to show that ht is equal to gamma p into gamma q divided by gamma p plus q into t to the power p plus q minus 1. T is greater than equal to 0, and p and q are positive constants. Now how do we go about it? Right now we have just studied a property that was Laplace transform of ft gt is equal to f of s h of s g of s f of s and g of s, and Laplace transform of ht is this one. So this is h of s. So we have to find h of s. I will find h of s, and then I will take the inverse Laplace transform. And what we are using? The convolution property. What is the Laplace transform of ft? Fs This is t to the power p minus 1. We know that Laplace transform of t to the power n is equal to n factorial by s to the power n plus 1. Alright. Now we are going to apply it. Here n is p minus 1 factorial divided by s. So if n is p minus 1, so n plus 1 is p, so s to the power p. Similarly, we can find for g of s. This is equal to q minus 1 factorial by s to the power q. The same thing applies. Here n is q minus 1. So we get h of s. What it is? Multiplication of fs and gs. So this amounts to p minus 1 factorial into q minus 1 factorial divided by s to the power p plus q. If we multiply both in the denominator, the exponent get added. Now what we have to do? We have to invoke inverse Laplace transform. Before we do that, let me write one use of this property. Gamma n is equal to n minus 1 factorial. This is the one that we are going to use. This formula and this formula. So when we say gamma n is equal to n minus 1 factorial, so we can say p minus 1 factorial is equal to gamma p. Similarly, q minus 1 factorial can be written as gamma q. So this becomes gamma of p into gamma of q divided by s to the power p plus q. Now all we have to do, take the inverse Laplace of this one. We will be doing it. So h of s is gamma p gamma q divided by s plus p plus q. Now we have just now used this property, Laplace transform of t to the power n is equal to n factorial by s to the power n plus 1. Similarly, what will be the Laplace inverse of 1 by s to the power n plus 1 is equal to t to the power n by n factorial. So here n is equal to p plus q minus 1 because we are adding plus 1. So we have to take minus 1. So what will be the Laplace inverse of ht? Pretty much clear. Here t is n is p plus q minus 1 and n factorial is p plus q minus 1. So we can write is gamma p gamma q t to the power p plus q minus 1 divided by gamma p plus q, because earlier we have just said that gamma of n is equal to n minus 1 factorial. So minus 1 factorial, that in terms of gamma function, and plus is added, so this is the answer. So this was a civil services question, and it is even pertinent to this day because civil services question paper is all about understanding the concept, its origin, how it comes, its derivation, and finally the application. Thanks for watching.